Hello, my name is Paulo, and this is my brief presentation for ESSE 2210. Today, I will give my thoughts about the sun's energy, cycle, and eruption. So let's start. Let me talk about the sun. Sun is the primary external energy source of our planet. It provides us with sufficient heat and light for sustaining life. Our plants need it for photosynthesis, which is the transformation of energy for growth. In this way, herbivores feast on these as their source of energy. This ultimately creates a cycle, which is how the earth has allowed life to flourish for millions of years. Sunlight is also used these days as an alternative source of energy, which reduces greenhouse gas emissions. So, what is the source of the sun's energy? We do know that our sun is made up of hot gases, mainly hydrogen and helium, where the latter is produced by combining four hydrogen atoms. The energy is produced in the inner core of the sun and is in the form of gamma rays. In the inner core, the energy generated gets out in the form of radiation. At the core, gravity pulls all of the mass inward and creates an intense pressure. The pressure is high enough to force atoms of hydrogen to come together in nuclear fusion reactions, something we try to emulate here on Earth. Two atoms of hydrogen are combined to create helium-4 and energy in several steps. First is two protons combined to form a deuterium and a neutrino. Second, a proton and a deuterium atom combine to form a helium-3 atom and a gamma ray. Two helium-3 atoms combine to form a helium-4 atom and two protons. These reactions account for 85% of the sun's energy. On the other areas, the energy escapes in the form of convection. We know that atoms have several positive and negative charges. The attraction between these two charges determines how strong the bond is between atoms. On a molecular level, atoms collide with each other, forming subatomic particles like protons and neutrons. In extreme conditions, like extreme pressures and temperatures, it is possible for several atoms of one type of element to merge together to form a different element. This is a type of a nuclear reaction called nuclear fusion. Nuclear reactions release large amounts of energy. The total mass of the product atoms has slightly less mass compared to the total mass of the atoms that went into the reaction. The extra mass is converted into energy, and it is governed by one famous formula, where E is the energy produced, m is mass of the object, c is the constant speed of light in a vacuum. The sun is known to have strong magnetic fields, and these are observed through the occurrence of sunspots. The sun has a 22-year magnetic cycle, which describes the number and location of sunspots. These solar activities also affect radio frequencies and telecommunications here on our planet. It is calculated that the surface temperature of the sun is around 6,000 degrees Celsius. Knowing these, a new question arises. For how long will the sun be able to produce energy enough for sustaining life here on Earth? It has been theorized that the sun already used about half of its hydrogen reserves in the last 4.6 billion years since its conception. Eventually, these hydrogen reserves will run out and our sun will be forced out to fuse helium and other elements. However, in doing so, the sun will contract under the weight of its own gravity. As the core contracts, it heats up and this heats the upper layers, causing them to expand. At this point, they will be called a red giant, which is a dying star. Earth at this point is sure to have been disintegrated. The sun will not be stable at this point and will lose mass. This continues until the star finally blows its outer layers off. The core of the star, however, remains intact and thus become a white dwarf. Do not worry, this process takes about several billion years so that the event will have passed thousands of our generations. So, our sun has been supplying us with the energy that we need for billions of years now, and will continue to do so for another 5 billion years. This energy harnessed is a good alternative for human use, instead of using fossil fuels which contribute greatly to global warming. Also, it is safe to say that using solar energy is sustainable since our sun will not go away anytime soon. So this concludes my short presentation, and I hope you enjoy it. Thank you very much.